Hello everyone. In this video, we're going to be evaluating an exponential expression. We were given 24 to the power 1 minus 1 over k is equal to 3, and we're supposed to evaluate 2 to the power k. First of all, let me tell you, we are supposed to find a numerical value from here. It's not going to be in terms of k or anything else, but we're going to find a numerical value. And let me also tell you that it's not going to be an integer. So I'll be presenting two methods here, and let's start with the first method. Obviously, my first method is going to be a little bit more painful. That's the fun part. And it's going to be a little time consuming. Hopefully not too long. You know, I'm trying to keep the videos short, but some people said we don't really care about it. You guys are amazing. I mean, I really appreciate your support and all those beautiful comments that you write. Anyways, let's just get into the problem. So we have this given expression. How can I manipulate it to get 2 to the power k? So I'm going to be, for my first method, I'm going to log both sides. And the base doesn't matter. You can use any base, but I'm going to use base 10. But again, you can use any base. Why not base 2 or base 3? You could definitely do that. Since we have the 3 and 2 as the bases, you could also use that. You could even use base 24. Again, it doesn't matter. But I'm just going to use base 10 because base 10 is fun and you don't even have to write the base. I know some folks are saying like, hey, when you don't write the base, it's natural logarithm. Yeah, I know Wolfram Alpha takes it that way, unfortunately, but what can you do? So anyways, I'm logging both sides. And when I do, now why do we log both sides in an equation, right? What's the purpose? The purpose is to get rid of the exponents. That's the sole purpose. Because logs have interesting properties, and one of them is log a to the power n can be written as n times log a. Of course, you have to talk about the domain. A to the power n must be greater than 0, a must be greater than 0, so on and so forth. But given all those conditions, this is true. Okay, great. So now we can move the 1 minus 1 over k to the front, and that is going to become 1 minus 1 over k. Let's put that in parentheses, multiplied by log 24 equals log 3. Okay, these are base 10, by the way. I'm not writing it down, but when I write log x, it means base 10. All right? Hopefully that makes sense. So now, obviously, it would make sense. Now, we're trying to look for what would make sense, right? Okay. We're trying to find 2 to the power k, so it makes sense to isolate the k term, 1 minus 1 over k. So let's go ahead and divide both sides by log 24. And then, since I'm trying to solve for k, why not isolate 1 over k? I can kind of switch around these terms because they are being subtracted on the left-hand side. So in other words, 1 minus log 3 over log 24 is the same thing as 1 over k. These can be switched. Basically, if a minus b is equal to c, then a minus c is equal to b, because b plus c is equal to a. Okay, hopefully that makes sense. I can just switch them real quick. And now I have something for 1 over k, but let's go ahead and make a common denominator. It's log 24 minus log 3 over log 24. Again, properties of logs are awesome, but they all come from the definition. Don't forget that. I can just write the difference of two logs as a log of a quotient. So in other words, this can be written as log 24 over 3, which is log 8. Awesome. That will be helpful to simplify. And since we have 1 over k here, not k itself, let's go ahead and flip both sides. And that gives us k equals log 24 divided by log 8. Again, these are in base 10. Okay. Now 24 is obviously greater than 8, and it's actually a multiple of 8. In other words, 8 divided 24, so we can kind of factor it and so on and so forth. We could probably do that, but let's not do it right now. Here's what I would like to do instead. I would like to use change of base. Change of base formula, as you know, is very helpful, just like any other properties of logs, but change of base is awesome. I can just write this as a log base 8, 24. Sometimes when I read it like log 24 with base 8, some people find it confusing, but I don't know how to say it like properly. If you know of a more proper way to say it, I will just say log 24 with base 8. Okay, so this is what I have for k. And remember, our goal is not to find k, but evaluate 2 to the power k. So it would make sense to substitute k here, and I end up with something like this. Great. So now, here's one thing to keep in mind. The base is 2, but if you look at the log, the base is 8. and 2 and 8 are related. Why? Because 2 to the third power is 8. Awesome. Yay. Okay, so I'm going to do the following then. I'm just going to make my base 8 because we have a really nice property, another property of logs again. But if you have something like 8 to the power log AB, then this just becomes B. So this base and that base kind of cancel each other out in the logarithmic sense. In the logarithmic world, they just cancel out and you end up with B. Make sense? Okay. Obviously, we can also apply it to e to the power ln x because ln means base e, so this is equal to x. Of course, x must be positive, so on and so forth. You know the details. So from here, I have a base of 2. I don't want it. I want 8. So why not write this as 8? Make the base, change it to 8. But then cube root it, because cube root of 8 is equal to what? 2. How about the exponent? We don't care. Exponent doesn't matter. Here, I can just cube root it. Great. Now, inside the radical, I have something super duper nice because 8 and 8 cancel out, leaving us with 24. Awesome. So the answer is cube root of 24. Obviously, you can write the 24 as cube root of 8 times 3. And the cube root of 8 is equal to 2. Therefore, this can be written as 2 times cube root of 3. I don't know if this is simpler than cube root of 24. Some people think it is, at least if you're adding or subtracting radicals. It makes sense. Anyways, that is the answer, and let's talk about the second method now. Obviously, my second method is shorter and nicer and cooler and, you know, so on and so forth. All these good things. I don't know. You'll decide. Maybe you like the first method better. Who knows? So for my second method, I'm going to break this down. I'm going to use properties of exponents instead of properties of logs. So we can write this as 24 to the first power divided by 24 to the power 1 over k. And that is equal to 8. I mean 3. Oopsie, I gave it away. So anyways, my question at this point is 24 divided by what number equals 3? A lot of times I ask this to my algebra students, like, because a lot of times they try to cross multiply, so on and so forth, divide both sides by blah blah. You don't need that. 24 divided by what equals 3? The answer is 8. Awesome. So from here we can write 24 to the power 1 over k is equal to 8. Remember, our goal is to find 2 to the power k. And do you think you can find 2 to the power k from here? If not, then you must review exponents. Okay, here's one thing I can do. I have an 8 on the right hand side, which is a good sign, and I have 1 over k, so why not raise both sides to the power k? Doesn't that make sense? Okay, let's raise both sides to the power k. Of course, k does not equal 0, everybody knows that, and we get the following, and 1 over k and k cancel out, leaving us with something much nicer, because we get 8 to the power k, which is equal to 24. But I'm supposed to get 2 to the power k, but no worries. We can write this as 2 to the power 3 to the power k equals 24. And then from here, you can switch the powers around because that's a rule. Just follow the rules, right? And from here, we get 2 to the power k equals cube root of 24. And as before, you can simplify this if you want. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.